Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to once again to all of you to the physics classes. We were talking about some of the concept of competitive exams, and in magnetism matters some of the topics we are going to discuss today. So generally what we have studied, that we have to recall first in the board examination or the board concepts. So magnetism and matter means it just deals with the magnet actually, right? So earlier moving charges and magnetism means because of the moving charges a coil behaves as a magnet. Now in magnetism actual because of the natural magnet and artificial magnet we are going to discuss. So artificial magnet is nothing but the thing we are going to discuss, what is the physics behind that. Natural magnet we know that is nothing but Fe2O3 or composition of iron or rock. So where the magnetic field already it is there, okay, it is developed. Why any material gives a magnetic field? Because all are consist of its own electrons, right? And electron behaves in the orbit means it behaves as if like a magnet, right? And so the total magnetic moment is got added and behaves as a magnet, but not every time, because those are all aligned, all are not aligned in the exact manner in some material. But the substances of iron like Fe2O3, ferric oxide and all, okay, they have arranged in a proper manner. That's why naturally we will get the magnetism. Now artificially I have to create the magnetic means what I have to do? I must take a solenoid, right? Bar I have to take and I have to coil the wire and I have to pass the current and I am going to get the magnet, right? So north pole we are going to get and south pole we are going to get, that is the thing. Now what is the physics, what are the formulations we are going to give, what are the notations we are going to give, that we are going to study. See, the pole strength we are going to write down it as m. See, certain pole, so it is having two poles, one is north pole and south pole, and it is together, okay. So that is the dipole. A magnet is nothing but a dipole is together, you can't separate that. You can't separate that dipoles, magnetic dipole, okay. So it is having certain pole length, pole strength, certain pole strength. The distance between them is 2L. Generally, the practically if you see means the geometrical length is, okay, geometrical length is somewhat, okay. So this is 2L we are going to take, okay, that is nothing but the distance. See, the pole will be nothing but north and south if you take means the actual distance between the north and south poles and the actual length of the magnet is different, okay. There is a ratio, there is not, see, geometric length is there. Geometric length is nothing but what is that you are going to find out by calculating, and magnetic length is nothing but actual distance between the north pole and south pole, and the ratio if you are going to calculate means you are going to get nearly 0.84. Actually one has to come, no, because both are same, no, but actually practically we are not going to get that. Now that same thing we are going to prepare here, no, okay. So this is nothing but a single coil behaves as if like a magnet, right? Single coil behaves as if like a magnet, no. So this magnet is nothing but the number of such magnets, no, so that a solenoid is formed. Solenoid is like this, no, north, south, north, north, south, north, south, isn't it? So that you are going to get the arrangement of the large magnets, that is nothing but a solenoid, right? So the pole strength, so poles appear slightly inside the ends of the bar magnet, okay. This is what the geometric length and magnetic length we have spoke about. Now you can give magnetic moment, okay. So magnetic moment is not that m, that magnet dipole moment we have written, isn't it? of electric field. Similarly, the magnetic moment into the length of the poles. Okay, the magnetic moment is nothing but the length of the poles. Now, pole strength, see, one magnet I am going to give you the pole strength or the magnetic moment. I can write down m is equal to m into 2l, or magnetic moment, the pole strength will be m, but on what factors actually it is depends on what factors actually it is depends on. Now, if I take this magnet little larger area means, so the pole strength is depends on the area of cross section, and also it is depends on the state of magnetization. Means how strongly you are magnetized, and also it is depends on nature of the material. These things are very important for you, because all maximum, I can say 70% of the questions may, or 80% of the question may come from this chapter as a conceptual one. Okay, the concept oriented one. It's like a theory based questions. Okay, conceptual questions you are going to get. Now, this is what m into 2l magnetic moment, the maximum times we are going to move. Now, what we have studied is simple. We can prepare a magnet only using solenoid. So, artificial magnet we took, and it behaves like this, we have studied, and there is a difference in the north pole and south pole, that is nothing but not exactly the magnetic length is geometric length and magnetic length is not same, that we have studied. And after that, what we have studied is, okay, so different factors that pole strength is depends, that we have studied. Okay, so like that we were talking about magnetic strength, magnetic pole strength and magnetic moment. Pole strength means it will be equal, okay, strength of this pole, or what extent it can produce the magnetic field, that is pole strength. The small letter we are going to talk. Sometimes we will minus and plus we are going to write down, otherwise m is enough sufficient to know, to make out that south and north pole, that's why we are writing, that's all. And what is magnetic moment? That is nothing but magnetic pole strength into 2l. Now, we were discussing, that is, yes, just now we have discussed, that is nothing but while dividing like this and dividing up, right? So, here the magnetic pole strength remains same, isn't it? The pole strength remains same. So, whatever the new magnet forms, the magnetic moment is decreases, Here magnetic pole strength is reduces, because the area of that magnet is going to reduce. Okay, so generally we know that we have written magnetic pole strength which is equal to magnetic moment which is equal to m into 2l, that is the magnetic pole strength. Now, for the different orientation, how, if you see in this chapter we are going to talk about only magnet, okay, the purely about magnet. It is not like that the concept we have discussed in the charge moving becomes a magnet. It's not like that. A particular magnet, bar magnet we are going to talk, and I am going to do the experiment. Maybe it is alignment, maybe it is the magnetic strength, the pole strength, in that way. Now, while think about the magnetism and matter, you must have in a picture that we are talking about magnet. We are not talking about that circular loop behaving as a magnet and the physics of that. No, it is not like that. Okay, here just we are going to talk about a magnet, a bar magnet, alignment and the physics behind that field lines, all those we have written. Okay, so if you talk about field lines, again I can say, so just now what we have talked about, just simple things we have talked. Okay, so magnetic moment, if you ask, means that is nothing but magnetic moment. If you ask, means that is the, what is the SI unit of that? SI unit is nothing but ampere meter. SI unit is ampere meter, and after that, okay. So next, what is the SI? What is the dimensional formula? That is MLT, M0, T0, L1 and ampere. L1, okay, the one, okay, like that. For any of the quantity dimension formula they are going to ask, okay. 2L is the real and magnetic moment, okay, that is the thing, okay. Then pole strength is nothing but, okay. So like that we can write down. So for any of the quantity we were talking about, any of the quantity they will ask the dimension formula, okay, that you must write down, you must know for all the quantities. For that you must know the formula, that is important. Dimension formula is very important for any of the quantity, and that is a 100% question, okay, 100% question. One question will be there for the dimension formula, okay, that is the thing. Some of the things we have written on the board, there is nothing but variation of the magnetic moment, okay. So when a magnet you are going to cut into number of pieces parallel to the length, okay. Now the new magnetic moment is formed, okay. Number of magnets you are going to get. For the change in magnetic moment, what is that? For each number, what is the magnetic moment, that we are going to calculate. See, pole strength is divided because the area is going to change, right? Area is going to change. So that m it was, and now divided into n parts, the pole strength. So total magnetic moment is nothing but 2Lm, okay, 2L into 2L length is there, and m by n, that is nothing but pole strength. So together, but we know that already the magnetic moment was 2L times m, and 2Lm is nothing but this much. So we are going to get in this way, because 2Lm was the earlier magnetic moment. Now suppose I am going to divide, okay, equally in the vertical, okay, in the vertical plane I am going to, not along the length, perpendicular to the length, I am going to divide n parts. So pole strength will be remain same for the each part, pole strength remains same. No, if you cut it to same means the strength will be same, the magnetic moment changes, because length changes, right? So now length, your length is does not going to change, but magnetic moment changes, okay, like that. Now what is going to happen? Pole strength is m, we know. So magnetic moment is nothing but, we know that 2L into m. Now length is changed, how much? 2L is divided into n parts, no, 2L is divided into m parts, but m remains same. For the each part 2Lm is nothing but m again, capital M, so divided by n, okay, that is what we are going to get. So this is the actual magnetic moment for the original magnet. So same way they are going to ask the questions. Now if different orientation if you do means, now I have a magnet in different manner, I am going to arrange that magnet. So what is the actual magnetic moment or the net magnetic moment I am going to get? About that we are going to talk about. Say for example, I have a magnet, okay, single magnet. Now I have bent in this way, okay, so it will be north, south, north, south, north, in that way. So what is the direction of the magnetic moment? South to north, okay, south to north, in this way, right? But so if you bend equally means the magnetic moment is divided by 3, m by 3, isn't it? That is what it is going to happen. And the net magnetic moment, if it is the case, we can write down m by 3, okay, the net magnetic moment, okay, that is the thing. Now if suppose you are going to do the different orientation for the magnetic moment, or the different orientation of a magnet, means what are the different magnetic moments we are going to get, what are the different changes in magnetic moment we are going to get, that we are going to write, okay. So if it is in equal parts and I have arranged in this manner, okay, so north, south, isn't it? South to north, the two magnetic moment, and equal parts are there. So equally up, divided means the length becomes L and the length becomes L, because it was 2L, magnet length was 2L. Now divided in this way. What is the magnetic moment? What do you mean by magnetic moment? Magnetic moment is nothing but length into the pole strength, length into the pole strength. For this arrangement, what is the magnetic moment we are going to get? What is the magnetic moment we are going to get? That if you write down means total length will be how much? This is end to end point, that is the total length. Okay, so after that, what is the value we are going to get? That becomes the total magnetic moment, and if you calculate in that way, the newly formed magnetic moment will be half of the initial magnetic moment, half of the initial magnetic moment. So the magnetic moment is for m by 2, right, and m by 2. So we have, this is in x direction, negative x direction I can write down, this is positive y direction I write down. Total m will be, this is for m by 2 is for this, another magnet we are going to get the net magnetic moment, that is m by 2. Okay, for this it is in minus x direction plus m by 2, this is in y direction. So the net magnitude I can write down. So net, so we know that any vector if you write down means the magnitude will be ax square plus ay square, isn't it? So the magnitude here also, that is nothing but net magnetic moment. Together the total magnetic moment I can write down square root of, okay, m by 2 whole square plus m by 2 whole square, okay, and that is 2m by 2 whole square, it goes root 2 into m by 2, I can write down root 2, so it becomes m by root 2, m by root 2. In which direction? So this is the direction. Using triangle of vector addition you can make out. Okay, using triangle of vector addition you can make out, and the total magnitude of that magnetic moment, if you align those two magnet in this way, it becomes m by root 2. Okay, because I have divided, that problem is given in such a way that, okay, one magnet is there exactly divided into half, it becomes m by 2, the magnetic moment becomes m by 2, because pole strength was same, and the length is divided by 2 means it becomes m by 2, Total for this arrangement, what is the magnetic moment it going to become? That is nothing but m by root 2, That same magnet is bent into half of the circle, okay, not half, an arc. Okay, so what actually this is length? This length is 2L. We know that formula in the trigonometry, S equal to r theta we write down. No, here S is nothing but 2L, which is equal to r into theta. Theta is the angle. So we can write down 2L is equal to r theta. Okay, but this length we want. No, now length is decreases. The magnetic moment has to decrease. Now I will take the perpendicular for this, I will write down this as y, this as y. Okay, this becomes theta by 2. Sine theta by 2 is nothing but, okay, sine theta by 2 is nothing but opposite by hypotenuse. Y divided by hypotenuse is nothing but y by r. Now what is the magnetic moment? What is the magnetic moment? That is, magnetic moment is nothing but, change in magnetic moment is nothing but 2 into y. The total length is 2 into y, isn't it? 2L was there, 2L is now the shortest length, 2y into the magnetic pole strength we have to write down. That magnetic pole strength we have to write down. So what is the value we are going to get for the pole strength? So theta by 2, okay, so y by r we are going to get, theta by 2 is nothing but y by r we are going to get. So hence we know this. So what is 2y? So y is equal to r sin theta by 2, 2y is nothing but 2r sin theta by 2, which is equal to 2r sin theta by 2 into m. R I can write down, R I can write down 2l by theta. So I am going to write down 2 into 2l into m into sin theta by 2, isn't it, divided by theta, divided by theta. So 2l by m is nothing but actual magnetic moment, okay, into 2 sin theta by 2 divided by theta, that is the newly formed magnetic moment. Now the question is, there are several orientation, how I can remember this equations, should I by heart it, okay, or should I do is no, you learn the way how that concept is developed, that is sufficient, no need to by heart, okay, no need to by heart, okay. This is the general case, you must know, this is the general case, you must know. And if it is subtended by angle theta, now the same thing we are going to take for if it is pi by 2, what is that, if it is theta is equal to pi, what is that, those are all we are going to talk. Now angle was theta here, and that is the case for angle theta. If suppose one more concept is there, now okay, this I can write down, no, the angle is pi by 2. So here theta must be in radians, must be in radians. Now pi by 2 if you are going to apply means m is equal to 2m sin pi by 2 means pi by 4 you are going to get, divided by pi by 2 you are going to get, it goes there, 2m pi by 2 is 1 by root 2 into 2 pi you are going to get, root 2 into root 2, root 2 cancel, so 2 root 2 m divided by pi you can get, 2 root 2 m divided by pi, that is what nothing but the new magnetic moment, okay, which is arrived, or m is equal to m by root 2, that also okay. In this way we can write down the magnetic moment. If a magnet is bent, okay, it a magnet is, so don't be confused that we have taken a half coil there, that we have cut, it's not like that. Here magnet I am going to bend, magnetic moment is that, magnetic pole strength is there, don't relate this magnet to that of the coil, it is bent, that is also behaves, that is a charge, the current is moving in the half, okay. So together coil becomes a magnet there, okay. So but here, and that is the magnetic field we are going to find out. Here it is, because of the magnetic field, its pole strength, some magnetic moment is created, okay. That magnetic moment is nothing but length into the pole strength, and for that case we have applied this. And if suppose, which makes an angle theta, earlier it was in this way, if you are going to write down in this way, that is 90 degree, okay. What is that happening, what is the value we are going to get, that, okay. So that way you found. Now if suppose one more case I can say, that is theta is equal to pi, theta is equal to pi means, now in this way north and south I have aligned, this becomes pi, okay. So it was in this way, right, the angle between them was theta, means somewhere, okay. Now you are going to take it as pi, the angle between them, okay, the angle I can write on it as pi, okay. So if theta is equal to pi means, what is the value, okay, m is equal to m into 2 into sin pi by 2, that is 90 degree, divided by pi by 2, which is equal to 2 into m into sin pi by 2 is 1, which is equal to 4 by pi. 2 goes to the numerator, and newly magnetic moment, changed magnetic moment, the changed magnetic moment you can write down 4 times m divided by pi. And if it is 2 pi means I am going to make it as a circle. First what did I do? First I consider in this way. Okay, it was subtending an angle theta. Okay, now what I will do, I will arrange in such a way that I will do the arrangement in such a way that that angle is goes on decreases or increases. The same magnet I am going to take it as to this pi. Now what I will do, I will coil it and I will make it 360 degree, that is 2 pi. Okay, theta becomes 2 pi. So theta becomes 2 pi means what? Okay, it's going to become 0. It's going to become 0 for theta is equal to 2 pi, m is equal to 0. Means there is no magnetic moment for theta is equal to 2 pi if the magnetic orientation we have done in that way. If the magnetic orientation we have done in that way, there is no magnetic moment arised. If suppose already magnetic moment is given for the bent magnet like this. Okay, now what I am going to do, I am going to make it as a straight. It was making an angle theta, subtended angle is theta. Okay, that can be any angle. Okay, so that can be any angle. So now theta was there. Now what I will do, I will make it straight as a bar magnet. Then the newly formed magnetic moment, which is equal to m, that is magnetic moment of this into theta divided by 2 sin theta by 2 sin theta by 2 we are going to get. This is the vice versa case. First what we are going to do, the straight magnet is there, I can make it bent like by arc of an circle making an angle theta I can write down, or I can subtend in such a way that okay, so the angle may be 180 degree and I can make it a 90 degree. Okay, so such orientation, if you consider different orientation, the magnetic moment will be in the different manner. Okay, like that it is. Now magnetic field, see dipole we have written electric dipole, and electric dipole field we have written on the axis as the equatorial plane, right? So here also magnetic field is there. See at this point, because of the north, that is magnetic field is in that way, because away from that. So because of the south, that is in this way, right? So d is the distance from the midpoint of the magnet. Then on the axis we are going to get 2 times md divided by d square minus l square whole square, and this is nothing but m is equal to 2l into m. Whereas if you consider the consideration where d is equal to very much greater, this is very much greater on the axis, means we can write down, we can get this formula. Now suppose on the equatorial means, so we can say that is equatorial position, or else it is perpendicular bisector. Okay, or equatorial plane. Okay, so equatorial plane, if any point if you consider means, again we are going to get some different magnetic field, that is B, which is equal to mu naught divided by 4 pi into, do you remember what we have written for the electric field, that is P divided by d square plus L square to the power 3 by 2 to the power 3 by 2. Again we are going to do some consideration, that is d is here, that d is very much greater, than L, means the same thing we are going to get, that is nothing but B, which is equal to mu naught divided by 4 pi into m divided by dq, m divided by okay dq, where 2 times we are going to get, here it is single time, one time, okay, isn't it? That is a relation, okay, and that is a relation, 2 times and 1 time, as we have written for the electric field, same. So derivation is there, we are not interested in the derivation, okay, we just remember, we have to remember the equations, okay. So similar to the electric field equation, so consider those electric field equations and relate it to here to the magnetic field equations, which are very much important, or sometimes direct formula, direct questions may come, okay, to find out the magnetic field because of that magnet. Then we must be able to find out the magnetic field. So what is the direction? Direction of the B on the axis will be, see, on the B on the axis will be, okay, so at this, nearer to this means we can write down towards south, okay, and at this point means away from the north, because of the south this is weakest field, this is the strongest one, right? So in that way it is depends on the orientation, it depends on the point where we are going to take to find out, to tell the direction of that magnetic field, okay. So different problems, different orientation, different point we may ask to find out the direction, okay. Usually you have to get the answers here, okay, like that, or direct formula also may come, okay, that is the thing, or some different changes they may ask in the problem. While we are going to deal with the problems, we are going to get the clear idea for that. This is what some of the topics we have discussed in a mixed manner, okay. So about only magnet we are going to talk about little bit topics, little bit some of the formulas we are going to talk here, okay. That is what little bit we have discussed, and remaining we are going to talk in the next videos. Thank you very much.
Don't forget to like our video and subscribe our YouTube channel for all the updates.